In this one here, we're going to look at the slope y-intercept form of lines. So with the slope y-intercept form, what we're looking at is the certain form of the line. We'll look at each component here and then put them together. So starting with the slope portion, the slope of a line describes the rate that a line increases or decreases vertically as it moves horizontally to the right. And that is pretty technical, sometimes confusing. So let's look at that on the graph here. We read the graph and we look at the line on the graph. As we go across the line, we start at the left side over here and we move along to the right. So we're always moving from the negative to the positive direction on the x-axis. We're always increasing the value of the x when we read it. So we are reading this way here. So always go that way on the x-axis as we read. The slope measures the change that way in the rise of the graph. So how much is it going up or how much is it going down in some cases. In this case, it's going up. And here I have a rate triangle to illustrate that. It shows the rise, which is the change in the vertical direction, and the run, which is the change in the horizontal direction. And the rise over run allows us to use some nice whole numbers, which are much more convenient to work with than trying to use decimals. So in this diagram here, I have a rise of 1, a run of 2. So the slope of this line, which is the rise over the run, m being our value that we often associate with slope, we see that the slope is 1 over 2. So that's our slope, 1 over 2. 0.5 is also acceptable as the slope. However, when we start working with decimals, the problem becomes if we work with 1/8, then the decimal would be 0.125. So trying to go up, okay, I'm going to go up 0.125. That's about right, and it's hard to exactly get it somewhere in here, where if I was counting 1/8, so a rise of 1 and then count over 8, that is much easier to do and more accurate. So we often leave the slope as a fraction when possible or when it's convenient to the situation, especially for graphing. What the slope gives us now is that from any point on the graph, we can find another point by going up 1 and over 2. So if I start here, at this point, I can go up 1 over 1, 2. I've hit another point. Up 1 over 1, 2. I've hit another point. Up 1 over 1, 2. I've hit another point. Even if I was to start at the half, I could go up 1 and over 1, 2. And again, I'll hit the line. So this is a way of giving directions from one point to the next, starting at any point. The other component that we need to look at is the y-intercept. So that's the second half of this, slope and y-intercept form. The y-intercept is simply the point at which the line crosses the y-axis, or the vertical axis here. So this point here, right here at -1, is where this line crosses. That is the y-intercept. It's just the point that the line touches or crosses the y-axis. We often use the letter B to represent the y-intercept. And if we put it all together, what we get is that the slope y-intercept form is written as y equals mx plus b. The slope times x plus the b value, or the y-intercept. So the slope is always times x. Okay? So if you have a slope, it's always with x. The number not with x by itself over here, that is always going to be the y-intercept. There is never going to be a situation where you multiply the y-intercept by the slope. In this diagram here, I've drawn a little rate triangle. It goes down 1, so the rise is -1, and the run is 1, 2. So my rise over run is -1 over 2. It crosses the graph at +1. That's my y-intercept. So the slope is -1 over 2. So I get -1 over 2x with +1 because the y-intercept is +1. And there would be the equation of that one line in the diagram.